When we look up at the night sky, we often marvel at the stars. Yet, hidden in plain sight is Andromeda, our closest neighboring galaxy, holding secrets that could reshape our understanding of the universe. From its immense, supermassive black hole to newly discovered, baffling structures, Andromeda offers a glimpse into the cosmic mysteries waiting to be unraveled. Andromeda, also known as M31, is a barred spiral galaxy over 2.5 million light-years away, visible to the naked eye on clear nights. Stretching over 220,000 light-years, it dwarfs our Milky Way, containing about 1 trillion stars. At its core lies a supermassive black hole, 35 times larger than the one at the center of the Milky Way, with a mass equivalent to 140 million suns. Orbiting Andromeda are smaller satellite galaxies, much like how our moon orbits Earth. These satellites, including M110, are gravitationally tethered to Andromeda's immense mass, creating a cosmic ballet that has fascinated astronomers for centuries. Andromeda is more than just a beautiful spiral of stars. It's heading straight for us. Traveling at 112 kilometers per second, Andromeda and the Milky Way will collide in about 4.5 billion years. But don't worry, this isn't a destructive event. When galaxies merge, their stars are so far apart that direct collisions are rare. Instead, gravitational forces will trigger intense star formation, creating bright young stars and reshaping both galaxies into a new one, the Milkomeda Galaxy. The Andromeda Galaxy, often considered well-studied and familiar, recently revealed a stunning secret that has astronomers questioning what else might be hidden in plain sight. Using a modest telescope and a unique approach, a group of amateur astronomers captured something extraordinary: a massive, ring-shaped gas structure almost as large as Andromeda itself. This structure, which emits a faint blue-green glow, had gone unnoticed by the world's most advanced telescopes for decades. How could something so massive escape detection? The answer lies in its composition. The structure is made of incredibly fine, ionized gas, similar to the delicate rings around planets like Uranus or Jupiter. Such materials are nearly invisible without specialized equipment. These astronomers used a filter designed to detect light from doubly ionized oxygen. This technique revealed the ethereal structure in vivid detail, something that's invisible to the human eye and most observational methods. Their findings were so remarkable that professional scientists confirmed the discovery using telescopes in France, California, and New Mexico. Interestingly, this gas structure shows no signatures in X-rays, ultraviolet, or infrared light, wavelengths typically used to detect such phenomena. This anomaly deepens the mystery, raising questions about its nature and origin. Could it be a previously unknown type of intergalactic formation, or perhaps an entirely new phase of galactic interaction? There are some possible explanations for the structure. As Andromeda and the Milky Way move toward their eventual collision, their vast halos of gas and dark matter may already be interacting. The structure could be an early sign of this cosmic merger, where gravitational forces compress gas between the galaxies, triggering emissions visible as this ring-shaped cloud. Also, Andromeda has a history of consuming smaller galaxies. This structure might be a remnant of such an event, a stream of gas pulled from a now-absorbed dwarf galaxy. Its unique composition could explain the unusual oxygen emissions detected. Another possibility is that the structure represents a giant emission nebula. These formations are created when intense radiation from hot stars or supernovae ionizes surrounding gas. However, the size of this nebula and its composition make it unlike anything we've seen before. Andromeda is part of the local group of galaxies, a cluster bound by gravity. Beyond its spiral arms lies a vast halo of gas, dust, and dark matter extending hundreds of thousands of light years. This halo is part of the cosmic web, a network of filaments connecting galaxies across the universe. The interaction of halos, such as those of Andromeda and the Milky Way, provides insights into galaxy formation and evolution. These gaseous regions supply fresh material for star formation, playing a crucial role in shaping the universe. Despite being one of the most studied galaxies, Andromeda continues to challenge and fascinate astronomers. Its vast size, dynamic interactions, and mysterious structures hint at secrets yet to be uncovered. Let's dive deeper into the unanswered questions and future mysteries of this incredible galaxy. At the heart of Andromeda lies a supermassive black hole, 140 million times the mass of our Sun, far larger than the Milky Way's Sagittarius A. This raises a fascinating question. Why is Andromeda's black hole so massive? One theory is that Andromeda has undergone multiple galactic collisions, feeding its black hole with gas and stars from smaller galaxies. Observations of X-ray flares and rapid gas movements hint that the black hole may still be growing. Future telescopes, like the James Webb Space Telescope, could provide detailed insights into its behavior and history. Dark matter, the invisible substance that makes up most of the universe, plays a significant role in Andromeda's structure and movement. Its halo, dominated by dark matter, provides the gravitational glue holding the galaxy together. Scientists are using Andromeda as a natural laboratory to study dark matter, analyzing how it shapes the galaxy's rotation and interactions with nearby structures. Could the strange, ring-shaped gas formation be influenced by dark matter's gravitational pull? Or might Andromeda's dark matter halo hold clues about the universe's missing mass? With over 1 trillion stars and countless planets, Andromeda is a prime candidate in the search for extraterrestrial life. Its vast size increases the likelihood of habitable zones, regions where liquid water could exist on planets. Future missions and telescopes may one day detect atmospheric signatures, such as oxygen or methane, on exoplanets within Andromeda. Could this galaxy harbor intelligent civilizations or even ancient relics of life? While we may not know for centuries, Andromeda represents a tantalizing possibility in our quest for answers.